Hello, my friend. I'm so happy to see you. Just going to give you an update about the optimizing work and the LOD I've been working on. And as you can see here, we now have three models. We have a vertical only, the original model, and over here we have a LOD object. Well, I'm going to explain that later, but just to let you know that. Just let's disable all optimizing for now. Just to let you know that I now put in some FPS test you can perform, so you can see what it does to the optimizing done. Here we can just try to add a few of these. Well, 500 of these as a test, and disable VSync so we get the proper FPS. Now we can just try to change the LOD distance. Let's just do that first, like this, and you can see this is the point where it switched to Vertex colors. If we go, you see here is the switch. Just make it at a larger distance. Here we have the switch. Oops, okay, and then let's try to do a FPS test. Here we have our 500 models. You see the FPS is 52 to render these. Well, the object is 13K triangles, so or polygons. So it's not that heavy an object. But if you put all this together, you can see, well, you have 6.4 million triangles it has to render. Same with the shadows. So that's a pretty large amount, and that's what really draws the FPS down. See, we only have 4 draw calls, but again, it needs to render all the triangles. So that is a bottleneck when you get many triangles. But let's just try to look at the vertex color only LOD system. You can see it's in action here. All of these are changing. When I move closer, you can see the change from texture to vertex color only. But now I'm actually optimized myself after this, because I made a change in the GameGuru MAX last week, so that I sent to Lina and that are now in the EXP build, that actually order these batches of draw calls into the absolute minimum. So we went from thousands of state changes to only a few hundreds on the same level. So what you can see here when change the LOD multiplier, which means now all is vertex color, and put it up here. Now all is textured object, and well, you will not actually see any FPS change. Yeah, a few. Not very much, 2 or 3 FPS or something. And that is because we have so few state changes now. So so I went further with this to see what we really could do about it, and I added a vertex welder that preserved the UV of the objects. We can just try to, well, let's just try to weld and put up the optimal. I also added a polygon reduction that keep the shape of the object, so you can't really see that it changes. Sure, there are small changes, but we'll just set it to 0.5, half the size, and then optimize the object. See now the LOD object, it has 6,000, 7,000 triangles. So that's around the half of the triangle count. So we just want to start the FPS test again. Here you go. You see now we are down to only rendering 3.2 million triangles, which is also a large amount, but you can see the FPS is nearly 100 now. Like this is the original object. Around 50, so we actually double the FPS. So that's a huge thing, trial count. So that is what I've been concentrating on among a lot of other stuff. So but let's just close this and I will show you how this is going to work. We will also just disable the vertex color stuff for now. I could make that faster so it also would work, but I'm not sure I should do that because the other stuff is working way better. Here, what you do now is you will select your level. We can just take the teaser, AstaKit teaser, and it will scan your level for all the unique objects you have and list them here in this list. So that is your whole level and all the objects you are using. And then you can select one at a time. I already optimized this and it gave a really huge FPS boost, but you can just try here. This is well, it's a very huge model and I'm not sure why it's so large, but just to show you. Oh, well, okay. I just we have the welding of the vertices on and full optimization, so this is going to take a little time because this model has many million vertex data that it needs to process, and yeah, I tried this and it can take up to a minute. So well, now we started it, so let's just finish it. And as you can see over here, you can actually now see the collision shape of the object, the custom collision shapes, and you can see the LOD model, or you can take the real objects when you need to optimize it. Oh, it's done at last. But now you can see here why this took so long, because it's 350,000 triangles or polygons, and it's been reduced down to 40,000. And well, there are not really any. This is the original objects, and well, this is the new object. Can you see any difference? Well, yes you can, but it's not really obvious. And that's with the optimal optimizing. So I will just save this. Save. I already have it, but let's just save it. That's all you need to do, and then it will create the LOD object. I will just disable this so we don't get it on this one again. Here you can see the LOD object. Here you can see the collision object. This is one that was included in GameGuru MAX, and you see it's only 7,000 triangles. But a lot of these objects don't really have a collision mesh that is really needed to get some proper speed. But I also included a function to make those, so we can just try to take this one, the cage object, and Normally the bullet engine would process all these triangles each time you enter it, but we can now weld them and reduce the polygon count. So it's only 2,900. Well, that's also a bit, but it's way less. So the bullet engine will love you for it. We can say that. And we now have a collision object, and it saves as OBJ file in the format that GameGuru MAX understands. And the real object. To better show you, we can select another level and work on. Perhaps this one can show it pretty well. Let's try that. Like this, you can see this one went from 64,000 to 2,610. And sure, you will can see differences, but there's no difference in the shape of the model itself. Well, it's also hard to see here. Yeah, well, it's harder shaped. The corners, you can see the corners here. It's not rounded like over here. So this is the ultimate compression, but that's also way below, and it will work pretty fine as a collision mesh. So I can just save it here, save the collision mesh. Chips, you can see we now have a collision mesh, and then we can start to optimize the object. I nearly always use .6. It gives a result where you nearly can't see any difference. Like so. You see here, it's still rounded like the other objects. This one. There's nearly no difference in how it looks. So the original, the reduced. So I would be happy to use that as a replacement object. So I can just save it here. Oops. You can see now we have a LOD object looking like that. We have our collision object, 2,600 triangles, the LOD 28,000, and the original take a little time to process. That is welding now with 46,000. So that's a huge difference. Just to show you what it gives, we can just close this and optimize it visual. Make a FPS test. Like so, and we have 500 of those. And should we display some data here? 42 FPS. Now let's put it at this level where you nearly can't see any difference and see what's going to happen to the FPS. 14 FPS here. Let's start it again. 64. So that's a pretty great increase. I was sure we can try to do it with instance on. It doesn't have any difference. It's still 13 million triangles. So now we can just try to put it down to the lowest one. Look at these two objects at this distance. Can you see any difference? No, you can't. So that is what I would try to put into the LOD instead, this one. You see here, we now have 180 nearly FPS and only 1.29 million triangles. So that's a huge difference. 180 FPS, and now the original objects. yeah, 43 FPS. So that is what I'm thinking about, making those very optimized LOD objects so we can get those triangle counts down. But let's just look at some more stuff that I made. Just disable this. And perhaps select another level. What could be? Yeah, well, let's just check. I think there is some animation in here also. Yeah, the Aztec warrior. He's a great sample for this optimizing, because now you can see you also have another option. I'll just remove this window. You now have something called Weld animation keys to compress data. And well, that is exactly what it will do. First of all, just look at them, how they look. The animations are the same, yes, that's fine. And then let's make a test here. FPS test. And that is updating of all the what do you call it, animation data that takes this time. It's a bit slow, so that's why when we weld the animation data, you can see here how many animation keys there is in total. 164,000. And that is just for a single object, not from all of them. This is the single object. So now let's weld it, get it down to 90,000, and we can do a FPS test again. And you can see here it goes down to 7 milliseconds. So we save 3 milliseconds. That doesn't sound like much, but I can tell you this is CPU time, so it is a lot, actually. And another thing that you should notice when we here, if we just try to, this is what we call raycasting, and the speed of raycasting. I'm just going to see if I can find a spot. What is happening when you, now the mouse is raycasting all the time, so what happens if I take the mouse down here? You can see there is a little reduction in the FPS, and this is because I'm hitting this bounding box, and then it's check if it is hitting. It has to analyze all the triangles inside that bounding box to see what triangle I'm actually hitting, or if I'm hitting anything. So you can imagine if I put the mouse here, well, it goes up to 20 milliseconds to analyze this. See, we don't hit anything, no bounding boxes. 7. Now we hit many bounding boxes, and you can see the updates goes up. The FPS go all the way down to 40 FPS, and now up to 60 FPS, and that is a huge thing as we are making many raycasts in a single frame. So what we can do now is actually reduce the polygon count of the actual animations and optimize it. You can see now this is the original, and this is the LOD version, and it only has 5,600 triangles. But let's start the FPS test again and check out what happens now when I take the mouse into all of these bounding boxes. Right here it was before. Well, you don't see any difference nearly. 7, 8. So that is a huge improvement in the raycasting by reducing the triangle count on these animated objects. So, well, this is what I wanted to show you this time. I have a lot of other stuff I'm working on, and now I need to somehow implement this into the GameGuru Max so it can run smoothly, and you can actually use all the functions to optimize your levels. You just going to just remove these tests. So we just go up here, select your level. I'm not sure if I optimize this one. Yeah, some of it. And so you can optimize all your animations and you can see here it's down to 8,000. Well, actually you could just use it as a replacement object if you are okay with that. Here we are nearly, no, let's just put it down to half of the triangle counts. And let's see if you can see any difference. This is the optimized model. This is the original. Do you see any difference? See the same. It's half of the animation key, so it processes way faster. And if you use, well, I normally use .6. It's the best, I think. I can never really see any difference then. Well, that is small differences, but I think it's a okay model with these few polygons or triangles. So, well, if you like me to continue all this work, please support me on Patreon so I can have some time to get it finished, and you can have a copy of the program. You can optimize all your animations and weld the animation data and control your polygon counts and weld vertices for the higher speed, and even make collision meshes for the bullet engine, so the physics will also get faster. So I hope you would like to support my work on Patreon. There is a link below. And if you like to see this kind of videos of optimizing and perhaps more details one, then please let me know in the comments below. And until next time, have a great day.